Hello. In this recording, I would like to go over the quiz number 18. You see, we ask you to use logarithmic differentiation to find the derivative, which you have seen some examples, right? So here we use logarithmic differentiation to find the derivative. To find the derivative dy dx. You will see that the advantage of using logarithm to find the derivative. The first one, as you can see, the first one can be found by just without using logarithm. However, you will see if you use logarithm, it's much easier. The second one, you have to use logarithm to differentiate. Okay, so let's start with the first one. The first one, we have the function y equals to square root of x minus 1 over x to the power 4 plus 1, right? Some of you try to use a quotient rule, which, it's not easy. Okay, chain rule and quotient rule. So let's use a logarithmic differentiation to see how easy it is. Okay, so number one, we take a logarithm on both sides. So we have this function given, and then we take a logarithm on both sides, natural logarithm. Okay, and the right hand side can be seen as a natural logarithm. Okay, and to the power of half. To the power half. By power rule of logarithm, we will have 1/2 of logarithm of the quotient. And we cannot then apply quotient rule. We can then apply quotient rule, which is going to give us 1/2. Okay, in the bracket, we're going to apply quotient rule. Logarithm x minus 1 minus logarithm natural log x raised to the power 4 plus 1. Okay, don't forget this bracket. If you want to write it in expanded form, you could remove this bracket, but then you have to have the half to attach to the second one. Either way is fine. So now we got ln y equals to, either form is okay. I'm going to choose the first one because we have a half as a constant. So the constant can be pulled out of the differentiation. So then we're going to take a derivative on both sides. Okay, so we take a derivative on both sides. So d of dx, right? We differentiate on both sides. And when we take a derivative on both sides, since half is a constant, so we can put this behind the constant. Okay. And then inside the bracket, we're differentiating a difference. So we can even write it this way. We can even write it this way, right? We're differentiating the first logarithm and differentiating the second natural logarithm. On the left-hand side, okay, is by chain rule. Derivative ln y, right? And then we're going to bring the dx over. And then we put dy, divide by dy, multiply by dy. So you guys should be fairly familiar with this operation. And then we got the first part that equals to 1 over y. 1 over y. And then we're looking, we want to find dy dx, right? On the other side, you can see we're differentiating this, we're using chain rule, and the derivative of that is going to give us 1 over x minus 1, and then multiply the derivative of x minus 1. And the next one we're differentiating on this piece is really chain rule, right? Because you would put it on the bottom part. Okay, so this is a scratch paper, right? So you would write it, you would see it as the derivative of ln u, right? du and du dx. du dx. But u is x to the power 4 plus 1. So this is our u, right? So in the end, we got 1 over u multiply the derivative of x to the power 4 plus 1 equals to 4 times x raised to the power 3. And of course, u equals to x to the power 4 plus 1. So this piece, after derivative really equals to that. Okay, and you can even put 4x to the power 3 to the top. Okay. So now we're almost done. So multiply by 1, it can be, simplified by multiplying both sides by y. Okay, so multiply both sides by y, so there's a y here. You can put it in the end, but y is really the whole of that. That was given. That's it. So that's finished. That's finished. Okay. Number two, we are differentiating tangent x raised to the power of 1 over x. But this function, we have to use logarithm to differentiating. So we're going to take a natural logarithm. Okay, so ln 1 and ln. Okay, and power rule. We bring the power, which is 1 over x, to the front. And then we get ln of tangent x. Okay, and ln of tangent x. So this is viewed as 1 over x multiply ln, a natural log of tangent x. And then we're going to take a derivative on both sides. Right, we're going to take a derivative on both sides. Take a derivative on the left-hand side. And then we take a derivative on the right-hand side, which is the product. So this is viewed as one function multiply another function, and then we take a derivative of the product. On the left-hand side, same as what we have done before. Okay, so I'm just copy and paste here. And the right-hand side is the product, right? So we can keep the 1 over x. Okay, multiply the derivative of ln tangent x with respect to dx. Okay, plus, and we're going to differentiating 1 over x, so ln of tangent x, and then differentiating 1 over x. Okay, that's the product rule. That's applying product rule. And on this piece, right, you're differentiating with respect to u. So let's write it out. Okay, the left-hand side would be 1 over y dy dx. And the right-hand side, right? So we got to work on this piece. Let's apply the chain rule, right? So that's our u. So that the u, right? So this is our u. That was tangent x du. Oops, du. And this is the u dx. Okay. And for a lot of you, you can just write it down. The derivative of ln u with respect to u is just u under 1, right? And u is tangent x. And the derivative of tangent x with respect to x is the secant squared. Right, so that part is done. That part is done. And the second part, the derivative of 1 over x is negative 1 over x squared. And here, if you write it this way, you must have the parentheses. But you can also write it alternatively, like in the next step, right? You can say, hey, I'm going to put this in the front of it. If you do that, you can remove, you can write it down this way. Okay, and then we're almost done. You can bring secant squared to the numerator part. And if this looks more compact, okay, so we can put this piece on top of x squared, right? And then, so this is the compact form. If you want to reduce it, you certainly can, okay? Because tangent x, okay, so let me write one more step. Tangent x equals to sine x over, okay, sine x over cosine x. Secant squared, okay, secant squared is 1 over cosine square x. Okay? And this is cosine square x, and this is cosine x right here. So you can be left with the following. Okay? So you're gonna have sine x, and one of the cosine x is reduced, so cosine x. So you have sine x multiply cosine x, right? So you can write it that way. You can even write it down. They're just next to each other. Oops, this should be in the denominator. Okay, so 1 over sine x cosine x. That works too. Okay, but anyway, it's fine. You just have to multiply both sides by y. So in the end, we multiply both sides by y, but be sure you have a bracket for the difference, And then y certainly will be replaced by what y is, and that's done. That's done. Okay. Some of you, there are a couple of those on the quizzes. They try to do the quotient rule, the chain rule and quotient rule, and that will work too. But however, that was not what's required of you. We do want you to be able to do logarithm differentiation to find the derivative. Now, if you have any questions, please don't hesitate to let me know. And also, you need to know the properties of logarithm really well. And you can see, they can be very useful and make things much simpler than it was when we are looking for derivative. Okay, so without further ado, and we try to keep this recording short. Let me know if you have any questions. Thank you for watching.